Hi everyone. Today I will walk you through the order execution engine platform that I have built. It simulates a complete crypto trade lifecycle, right from order intake to real-time execution updates. I have not utilized the real transactions, but I have implemented a mock quotation classes to get the quotes. Here is our post-order endpoint, and here is my WebSocket URL. This one. And now I'm going to utilize an API testing tool like Postman to see what is the status of my transactions. We can see here our method is post currently, and now I hit the send button to generate a random ID. Only after that we can build a WebSocket connection to see the actual transactions happening. We can see just right now the order ID changed. If I hit the send button again, it continuously generates random IDs. So I just copy it, and now I open a WebSocket connection from here. Previous from the I think there was a previous connection on. Let me disconnect it. And then what we are going to do is we are going to replace this previous order ID with our current order ID. You can see the status is still pending. I think I can generate some other in other duplicate tabs even. Yes, like here. Let me generate one. We can see again that a new random ID is generated. I go to the WebSocket connection again. I disconnect it. I replace it with this. As we can see, our transaction states, it was for the very first state. The order ID that we gave it to is just right now, and the status is still pending. That means the order has been received and will start the execution shortly. For the next pending, it is still, this represents the number of retries. We are only in the number attempt one stage. And now this routing stage compares different types of decentralized exchanges. For our project, it was Meteora and Radium. Still, the attempt is one. It is going to compare between both of the prices. So from our calculations, we found out that the best decentralized exchanger is Meteora for the current one, and then the status is routing. And now the next status is building with the order ID that we have just given it right now, that we have generated right now. And then slowly we can see all of the transaction states that simulates the real world. And lastly, the my status is confirmed, my transaction is complete. The best decentralized exchanger chosen was Meteora. And the only one attempt, no more than three retries has been performed. And here's the hash. And here's the final best execution price. This is my folder structure. In this folder structure, this is a Git repository, obviously, and here is the source folder. I've utilized the MVC architecture, model views architecture, where I have for order queue I have used Redis, which enqueues and dequeues. Here is my order controller. This order controller is being utilized here to receive, like, from the post API, the order type, to token amount, and the order type, from which crypto to which crypto I want to convert it. And here, this function, add waiting order, I have used this so that I can map the socket connection to its corresponding order ID. Basically, in the implementation, I faced some issues regarding circular imports, so that's why I needed to map the socket connections to the order ID. And here is my order queue, which implements enqueue order to Redis and dequeue order blocking. We can see here that I have utilized in Redis, I have created two separate connections to the same pool. It's because for the dequeue option, which is a blocking operation, it just freezes the operations and no push would happen. So I have created two connections. One is Redis blocking and one is Redis. In the order route, this is just the simple routing. Yes, the simple routing of the API. And Here is the mock implementation of the decentralized exchanger, consisting of the Radium exchanger and the Meteora exchanger, and both of the formula of the computation, how we are computing the prices, and how is it deciding between the best prices. And then I've got my this WebSocket connection manager file where as soon as a new random ID is generated, I quickly execute enqueue. I quickly push it to the Redis queue. As soon as I push it to the Redis queue, we have also our order worker, where continuously it is waiting. If the queue is not empty, it quickly pops from the start, and it again there we have our function process order with logging, where it simulates the real transactions, and we export this start order worker to the server.js, where at the time of initialization it starts. And it is a continuous process. As soon as the queue becomes empty, stops, and as soon as it enqueues something, it again starts the processing steps. So basically, this implementation which I have used is just a mock implementation. It's not some real transactions happening between the Solana blockchain or any other blockchains. And also, I would like to lay emphasis that can support concurrency up to 10 requests, and I can even show that. Like, let me duplicate the tab. I've got this here. I generate this here, and let me duplicate the WebSocket connection even. Let me just copy this one to disconnect it. Yes, two order IDs generated just right now. Let me switch it. Let me change it again so I'm confirmed. Yes, I replaced this previous order ID with the most current one from the first socket, and let me hit it again. A new is fresh random ID generated just right now. Second. Yes. Again, we can see simultaneously again the transaction status. Same for this as well. We can see we can simulate up to 10 concurrency. And also I have deployed this using the render platform, where I have used Upstash for the my Redis external instance. And this is my deployed URL. I've also mentioned the post order endpoint and the WebSocket URL. We can use any of the API testing tools. And this was the example. And also I've utilized the market type of order, where we instantly want to trade no matter whatever the price is in the market. So from the Solana blockchain, you have the Sol currency and then the US dollar, and the amount is set as one, and the order type market, as I just told right now. And this is how the simulation proceeds for this order execution platform. Thank you.